let's have a look now at the last of the graphs of the fundamental trigonometric functions, and this is the graph y equals tan of x. And again, we're going to limit our graph between the x values of 0 degrees and 360 degrees, because it's another graph just like sine and cos. It just keeps repeating over and over again forever. So again, with the help of a little bit of technology, let's have a quick look at what the graph looks like. Okay, this is graphed on the Casio FX-CP400. Okay, and what you'll notice here, again, I'll zoom in on that, is again, there's a repetition there, but something kind of strange happens as the function kind of approaches 90 degrees. Okay, so we're going to give it a chance to redraw there. Okay, and you notice that it gets sort of closer and closer to the line, x equals 90 degrees, but it doesn't quite touch it, does it? It happens every 180 degrees, in fact. Now I'll just go back to the beginning again. So just let this graph redraw. So it seems like something strange is happening at 90, and again at 180 degrees later at 270, okay, and then at 450, and so on. All right. So what's going on here? Okay, and this is something. It's actually a line called an asymptote. Okay, and it's we can never get an exact value or a value for tan of 90. Okay, so let's just focus on that for a moment. What's going on here at 90? In fact, if using the calculator, we've done this before. If we put enter in tan of 90, you get an error. Okay, you put in tan of let's say 89.999, you get a fairly big number. So tan of 89.999 is just before 90. The graph is sort of going off to space, isn't it? Right? Very big value there, right? Going off well off the screen. And likewise, if you go just after 90 degrees, okay, just that little bit after 90, and again, let's say we try to value 90.00001, you get an insanely small number. Right? In other words, it's large in the sense of sort of its actual value, but it's sort of on the negative side. Okay, so we call that a small number, not compared to 0, but it's sort of way off to the left-hand side or down below, on the y-axis there, depending on which axis we're talking about. So it's going sort of all the way down, sort of well up, again, way off the screen, but it doesn't quite. It can never touch. It can never be, it can never touch this line here at x equals 90. And again, we call that an asymptote. So apart from that, it's just a sort of looks like a cubic curve almost, y equals x cubed. And in fact, if we graph y equals x cubed, it kind of looks, somewhat similar to that. So anyways, that's that. Let's draw this now freehand. So I'll just take this away, and let's make sure we can draw this, okay, without any help from technology apart from a pencil or a pen and a ruler, of course. But I'm just going to draw it freehand for now. Okay, so again, drawing a set of axes there. Okay, let's try to draw it as neat and tidy as possible. All right, and there's x, there's y. That's actually in degrees. Okay. Now, first thing we know is that there's asymptotes at y equals 90. Why is there an asymptote? Oh, remind me. We'll answer that question later. So, okay. So an asymptote, we can draw an asymptote as a vertical line. In fact, you know what? Make my life a little bit easier. Why don't I use a ruler? Okay. Hopefully this will work out okay. Okay. Just problem is that it can smudge the whiteboard marker ink. So, all right, so something like that. In fact, we don't need that center one. Okay, only put that there so that I know where 180 degrees is. We try to space it out somewhat equally. Okay, so there's 180 degrees. Okay, this is 90 degrees there. This is 270 degrees there, and this will be 360 degrees there. Okay, now I might just actually I'll get this in the same color. Actually, no, I will change to a different color, and I'll draw it in red. Okay, tan of 0 is 0. Okay, and it sort of tries to touch it. It gets close to the asymptote, but doesn't quite touch it. So what we do, and you can put an arrow like that. Okay, and this is quadrant 1, by the way. We'll talk about the quadrants after this. Let's graph it first. We're getting ahead of ourselves. Okay, now same thing here. We draw what sort of looks like a cubic curve there. Be careful not to touch the asymptote. I sort of almost got close there. Okay, and lastly, sort of, there you go, and kind of, yeah, does that, doesn't it? Yeah. All right, so tan is tan of 0 is 0, tan of 180 degrees is 0, and tan of 360 degrees is also 0, and then it repeats itself, doesn't it? Sort of goes over and over again, and you see that there's a repetition every 180 degrees. In fact, there's it's sort of periodic. Why we call it a periodic function, because the same thing with sine and cos, because it just sort of repeats itself every so many degrees. It repeats itself, same thing over and over again. Now, back to the question is, why are these asymptotes there? How do you spell asymptote, by the way? Asymptote, with a P, right? It's a line that a curve will get close to, but never touch it, ever. Go to infinity, right? I mean, you can get ever so close to it, but it could never touch it, ever. All right, so there's two of these asymptotes there, at least between 0 and 360 degrees. So the question is, why is there an asymptote? Right? Why is there an asymptote at x equals 90 degrees? And also one at 270. We'll answer this one first. So just recall, remember what tan could be defined in terms of. Remember that tan of x really is just the same as saying sine of x over cos of x. Remember that? All right? We looked at the definition of tan in terms of sine and cos. Now, x is 90. All right? So tan of 90 degrees is equal to sine of 90 degrees over cos of 90 degrees. Now, sine of 90 degrees is a nice, well-behaved number, isn't it? Sine of 90 is 1. Great. Fantastic. We've got a numerator of 1. But what happens when you have cos of 90? Remember what the graph looked like? Cos of 90? 0. Uh-oh. So you've actually got a situation 1 over 0, all right? Which is, well, it's either positive infinity, right? Or it goes to negative infinity, depending on which side you're approaching the asymptote from. So if you're approaching the asymptote from the left-hand side, the graph goes to positive infinity. Approaching the asymptote from the right-hand side, so go back to 90, it approaches negative infinity. So it's kind of equal to a sort of plus or minus infinity, depending on which side we're approaching from. Which is, yeah, I don't know if it's nice or not, but it is as it is, and sort of that's one of the properties. And it sort of same property occurs at 270 and so on. Now, just quickly talking about the quadrants again. So here's our quadrant 1. Okay, quadrant 1, tan is positive. Okay, this is our quadrant 2. In fact, it's great to have the asymptotes there because they kind of separate out the quadrants. So thanks asymptotes. I don't have to draw dotted lines there, right? I'll just draw one here. Just do that freehand there. Okay, this is our quadrant 2. Okay, what's happening at quadrant 2? Where's the curve? The curve is negative, isn't it? Right, so let's put a little negative, bit of a big negative sign there. All right, and quadrant 3, what's happening there? The curve is positive again. Quadrant 4, okay, the curve is negative. So it's going positive, negative, positive, negative. All stations to central. Let's see what's going on. All stations to central. Tan is positive in quadrant 1, right? And that's confirmed in the graph, isn't it? The first between 0 and 90 degrees, not including 90, we can't have 90, of course. The graph is positive. All stations, all positive. Tan is negative in quadrant 2, okay? And that's represented here in the graph. Between 90 and 180 degrees, tan is negative. Now, in quadrant 3, T, 2, tan, tangent, right? That's plus, right? The graph here is positive from 180 degrees to 270 degrees. And likewise, from sort of also from 270 to 360, tan is negative. That's shown in quadrant 4. And that's negative here in quadrant 4. So we have positive, negative, positive, negative. And just every 180 degrees or every 90 degrees, it changes from plus to minus, minus to plus, plus to minus. Sort of a nice bit of a pattern there. Anyways, there's the graph of y equals tan of x degrees. Very, very important, make sure that you show the two asymptotes there. And of course, if you're asked to graph anything beyond 0 and 360, just remember, if you can graph this fundamental curve here, okay, this is it's actually 2 complete cycles here. You can just keep going sort of back the other way if you want to graph back to -90, of course.